So in the previous discussion, we learned that each element has its own chemical symbols, right? Yeah, some chemical symbols consist of one letter, some chemical symbol consists of two letters. If they have two letters, then there are uh, some rules, yeah, that the second letter must not capital. Okay, so the first letter is capital. And also, we have learned about the simple ions like a single atom, yeah, uh, sodium Na plus, K, kalium, chlorine, oxygen, and magnesium. Okay, they are all simple ions. And also, you guys have learned here that uh, in this slide there's something wrong. Everyone should be able, we should be able uh, to highlight this one that this is wrong. Yeah, the way we write it is wrong. It's supposed to be an A. Okay. And for the compound ions, they also have some ion is also not a single atom, but they are a compound. Yeah, example like sulfate SO4 2 minus, it has charge 2 minus, and then nitrate NO3, it has a minus charge, and also CO3, it has 2 minus charge. Okay, so the compound ion is an ion made of several different atoms. Yeah, they are bonded. They are bonded covalently between the three. This one has four atoms. This one also have four atoms. They are bonded covalently together because they are bonded covalently together. So when you mix them inside and pour them into the water, they will not separate. Yeah, they will not separate. If it's ionic bonding, then if you put them inside the water, they will separate. So they are bonded together with an overall charge. Yeah, this is the overall charge. Now, previously we have the example of charged ions. Yeah, the carbon and the three oxygen. The carbon atom number is 4. So on the outer shell they have 1, 2, 3, 4 electrons, and they have a bonding, yeah, double bonding here with the oxygen, 1, 2, 3, single bonding with the other oxygen. So because in the bonding, the electron that bond them together is on the skin of the carbon, yeah, it's on the shell of the carbon. So now the carbon have 1, 2, 3, 4, 5, 6, 7, 8 electrons. So now the carbon can be stable. Okay, and also about the oxygen, oxygen now have 1, 2, 3, 4, 5, 6, 7, 8. Now they can be stable. Okay, if we check here, the oxygen have 1, 2, 3, 4, 5, 6, 7, 8. They can be stable. Also this 1, 2, 3, 4, 5, 6, 7, 8 on the outer shell. Now they can be stable. So overall, we if we see the Lewis structure, this is called the Lewis structure. They are all can be stable, yeah, and their charge is 2 minus. This charge is one thing that we are going to learn. Okay, first of all, we see that the atom of each element have their own combining power, yeah, and this combining power we can see it is depend on how many electron that can bond, uh, that can create covalent bond on the shell. Okay, so in covalent molecule the number of bonds, uh, In covalent molecule, the combining power is equal to the number of bonds that the atom makes. Example here, there are two bonds and this one only have one bonds. That is the for oxygen, this one for oxygen, they only have one bonds. And this oxygen have two bonds. While the carbon have one, two, three, four bonds. Since the carbon have four bonds, yeah, then the combining power of the carbon is this equal to number of bond that the carbon makes. So it has, let's say the power is 4, okay, compared to oxygen the power is only 1 or 2. And then an atom having valency represents, valency is not necessarily to be remembered, yeah, but this concept can help us in understanding about the bonding, uh, uh, and also the creation of the formula. So an atom having valency, these these valency number will then determine the formula of the covalent compounds. Okay, now this valency number, this valency number is the one that we need to remember the pattern. Yeah. So this is valency. First of all, imagine we have hydrogen. This is possibly the easiest. Yeah. Hydrogen have one electron on the outer shell moving around them, right? So they do need to absorb one more electron so that the outer shell will be stable. Okay, so if we see here, hydrogen need one. What about magnesium? Magnesium, if we look at the periodic table, let's let's find some periodic table. Okay, here we have the, okay, let's look at this for a while. So we see here that magnesium atomic number is 12, yeah, it's 12 and it's in the group 2. Okay, now using this base, magnesium have the atomic power of 12. That means in the first shell it has 2 electrons. In the second shell it has 10 electrons. But we can only fill 8 electrons in here, right? So that means there's another layer consists of 2 electrons, 1 and 2. Okay, so between the hydrogen and magnesium, guys, let's take a look. So if they want it to be stable, there are two ways, yeah. First of all, hydrogen can actually attract one electron, okay. But remember, hydrogen only have one proton, yeah. So the way it pull electron is very weak. So there are two ways they can release the electron or they can absorb one electron. If they release an electron, there will be only positive charge and the charge will be positive, yeah, since one electron miss and one proton they have, their charge will be +1. What about magnesium? As well as the hydrogen on the outer shell, magnesium have two protons so they can attract, sorry, the magnesium have two electrons so they can attract 6 electron. But attracting 6 electron compared to releasing 2 electrons, the number is smaller in 2 electrons, so it is easier to release the 2 electrons. So if they release 2 electrons, they will lose 2 negative. That means their proton remain 12 while their electron only 10 left. So their charge will be plus 2. From here, let's see. From here, let's see on this. Yeah. So hydrogen here have one. It's in group one. Okay, and uh, the number here is plus one. Magnesium is in group two, and the number we created here is plus two. Okay. Now you can see here. You will see here a relationship between valency and this electron. Yeah, valency and the group number. Valency, uh, this number, yeah, that's the valency. Okay, for now, forget the plus sign. Okay, but let's check. For group 1 to 4, the valency number is equal to the group number. Okay, you guys can see that. Yeah, hydrogen group number 1 and the valency is 1. Magnesium group number 2 and the valency is 2. Okay, so this is for group 1 until group 4. Okay, the valency is equal to the group number. For group 5 until group 7, the situation is like this. Let's make an example. Let's see an example, guys, for uh, fluorine or Cl. Yeah. Example F. The number of F is 9. Okay. F have the number 9. So in the first shell, it has 2 electron, and then in the second shell, it has 7 electron. Right. So it is easier for them to attract 1 electron. There you go. If it attracts 1 electron, the problem is the proton is still 9. It still have 9 proton, but it has extra 1 electron. That means the charge later become negative 1 when it attracts. Okay, so this is the valency. The valency is negative 1. Okay, now for a while, let's forget the negative sign. Okay, but let's check. Since the outermost shell need 8 electron, now you guys can see here in group 5 to group 7, we have 8 in the beginning. Okay, and the group number of F is 7. So 8 minus 7 is equal to 1. So this is the valency of group 5 until group 7. Okay, for group A, because it has 8 electrons. Okay, group 8 example, uh, we can use this. 8 minus 8 is equal to 0. This is the valency number. Okay, this is the valency value. Because for group A, there are all of the place in the outer shell, yeah, already contains 8 electron already full. Okay, so there's uh, no more space left for any bonding. Okay, so remember this. Group 1 to 4, the valency is equal to the group number. Group 5 to 7, the valency equal to 8 minus group number, and group 8 has no valency. Now we put it on the table. This is group 1 until group 4 equal to group number. Group 5 to group 7 is equal to 8 minus the group number, and group 8, it has no. Yeah, okay, Now let's see. Group 1, the valency is 1. Group 2, the valency is 2. Group 3, the valency is 3. Group 4, the valency is 4. Correct, yeah? Group 5, the valency is 8 minus 5 equal to 3. Group 6, the valency is 8 minus 6 equal to 2. Group 7, the valency is 8 minus 7. So the valency is 1. Group 8, the valency is 8 minus 8. So the valency is 0. So the common compound for group 1, yeah, example sodium. Sodium usually uh, connected to the chlorine, yeah, NaCl. This is the sea salt. Okay, this is an example for magnesium chloride, and then aluminum with Cl, 3Cl, and so on. Yeah, example here chlorine in group 7 combined with hydrogen. Okay, now to uh, for a for a neutral compound, we can use this crossover method. Yeah. Okay. Example. We can use this crossover method to create uh, the compound formula. Yeah. Example: carbon. The valency is 4 because it's in group 4. Oxygen is in group 6, so the valency is 2. Okay. So we put here the valency. Carbon is 4 and oxygen is 2. Okay. Now multiply the valency with the uh, with the other atom. Yeah, they cross we crossover. So we have C and the valency number is 2. We have oxygen and the valency number is 4. Because 2 and 4 can be divided with 2, now we simplify this become okay. There we go. 2 divided by 2 is equal to 1. So we have only one C, and 4 divided by 2 is equal to 2. So if we simplify the equation here, C2O4, it becomes CO2. Okay, this is the way we create the formula of a compound. Okay, again, yeah, the C valency is 4. Let's use the laser pointer. Okay, the C valency is 4. The oxygen valency is 2. Then put here the valency of each. C is 4, oxygen is 2. And then multiply crossover. So 4 to oxygen, 2 to carbon. Yeah, this is because to make their valency equal. Yeah, so if we need to make the valency equal, we realize that we need one more oxygen, then they have equal valency. Okay, there's something wrong in here. This one, okay, there you go. Yeah, CO2. There you go. Okay, if you think mathematically, you can see example C. The valency is 4. To make them equal, oxygen, which valency is 2, need to be doubled. So if we have 2 oxygen, that means double the valency also 4. Then they they can be equal. Yeah, that's why we need 1 C and 2 oxygen. Okay. Now, if we work with the diagram, yeah, the molecular formula shows the actual number of atoms. Example, Bf, Br, bromium, and trifluorine. Yeah. So this is if we write equation, this become the center formula first. Right here, the center formula, Br F3. Okay, and then this one, the center atom is nitrogen, so NH3. In here, the center atom is the carbon, so it's C3H. Okay, what just happened? Let's erase this. How many H here? One, two, three, four, five, six. CH6. Okay, but remember, for this one, we do not simplify. Okay, for C3H6, we do not simplify because the compound is consists of 3C. Okay, so remember, we do not simplify this one. Yeah, simplification, say, or simplifying only happen when we do the crossover method using the valency, and then the last step is simplifying. This one, this one is, there really are 3C. Yeah. Okay, uh, met- this is propane. Yeah, propane. Okay, now about the formula of the ionic compounds. Yeah, the formula is equal again. Yeah, is equal to the number ratio of positive to the negative ions. Okay, this is the formula of ionic compounds. So positive first and then negative. Okay, first remember this. So the overall structure must be neutral. Overall, it says that overall structure must be neutral. Now we'll practice with magnesium and chlorine. So let's bring back the periodic table. Yeah, magnesium is in group 2. So the valency is 2. Chlorine is in group 7. So the valency is 1, correct? So how many needed? Let's keep magnesium 1, and let's make the number of chlorine, yeah, the number of valency of chlorine become equal to magnesium. So we need 2 chlorine, yeah. So 2 multiplied with 1 is 2, 1 multiplied with 2 is also 2. That means we need 2 chlorine, MgCl2. Okay. Okay, this is the first video. Okay, you guys can find the next assignment.